on paper. Okay, the coordinates of each vertex of a unit cube shown given below. So this is a unit cube given in the question, shown in the figure, is an input to a MP neuron. So MP neuron is like this. This one F, G, X1 and so on. These are inputs, Xn. So all inputs are belongs to 0, 1. For MP neuron, inputs and outputs both are Boolean 0, 1. That is belongs to 0, 1. Sum of threshold is sum of sigma I equals to 1 to n g of xi. So f and z both are functions and g is a aggregate of the inputs function, that is sum. G is a aggregate of this. So g is a g of xi equals to aggregation, that is sum. Sigma I equals to 1 to n xi. F is a function. F takes a decision. F takes decision. Decision, that is the output. Y is the output. So this y is the output and y also belongs to 0, 1. That is both input and outputs are Boolean in MP neuron. So y is a function of y equals to f of g of x. This one f is a decision function and z is a summation of the all the inputs, that is aggregate function. And y equals to 0 when the inhibitory input, if there is an inhibitory input, is on. Inhibitory input is 1 and y equals to 1, inhibitory input is 0. Two types of inputs, inhibitory inputs and excitatory inputs. So the inputs are, for MP neuron, the inputs are excitatory input, inhibitory input. So x1 to x10 all are called as excitatory inputs, x1, 2 and so on x. So the coordinate of the vertex is represented by an ordered tuple. So in the cube there are 8 vertices and each 8 vertices is represented with a coordinates x, y and z. That is, it belongs to R power 3, 3-dimensional. R power 3 and all the values of x, y, z belongs to 0, 1. That is, they mention in the question in MP neuron. That is, for an MP neuron, input and output both are Boolean. The vertex A has a coordinate of, so the vertex A is origin, that is, here this one is A and this coordinate is 0, 0, 0. Origin, coordinate of 0, 0, 0 and Z has a coordinate of 1, 1, 1. So this is Z and this coordinate are 1, 1, 1. And the vertices A, E, H, D are of a negative class. A, E, H, G are negative class. This one is H, E, F, B, C and D. These are the vertices. So A, E, H, D are negative class. So A is negative, this one. E is also negative, H is also negative and D also negative, and positive vertices. Remaining all are positive vertices. So this one positive, F, B is positive, C is positive, and Z is positive. Of positive class, the MP neuron uses the following decision rule. So this one is important, following decision rule, that is they predicted the y hat, that is the y hat equals to 1 if x1 plus x plus y plus z, x, y and z are inputs to the MP neuron greater than theta, x plus y plus z greater, otherwise 0. Otherwise 0. Where theta belongs to R, suppose that we set two of the points yz are always 0. That is, they given theta belongs to R and yz, y comma z are always 0. You can remember, this is very very important. Y and z are always 0. Then find the threshold value that separates this data point correctly. They are asking theta, threshold. That is the threshold value that it separates the data, linearly separable. Positive points on one side and negative points, that is it divides the entire plane into two half. From this, so in the question they mentioned y and z values are always 0, right? So y hat, that is the predicted value, y hat equals to 1, x plus y plus z greater than 0. So yz is always 0, that is 1 when x greater than 0. Put y and z are 0 and 0 otherwise. They given a equals to 0, 0, 0, that is x, y and z. X, y and z. That implies x plus y plus z equals to 0, which is less than theta. What is the threshold condition for the MP neuron? So this one, theta. Sorry, this value is theta, not 0. Theta, they mentioned theta. X greater than theta. So this value is 0, less than or equal to theta. So theta is the threshold value, it's not 0. Y hat is predicted value mentioned in the question 1 if x plus y plus z is greater than theta, not 0. So that implies y hat equals to 0 and b equals to, first we write all the 8 data points. Okay. So A 0 0 0 0 0, A given 0. This is the unit cube 1 1. Every distance is 1 1. So A equals to 0 0 0 and D equals to this one, x, z and y. So D is only y coordinate is 1. So x, y, z. Y coordinate 1 0 1 0. And next C is both x, y are 1. Both x and y are 1. That is x, y are 1 and z is 0. Next B point on the x-axis, only x coordinate is 1, rest all 0. Next data point EFGH. EFGH and H. So E. So E is on the Z axis, only Z coordinate equals to 1. So rest all 0, 0, 0, Z equal to 1. And F. F is on XZ plane. F is on XZ plane. So X and Z values are 1. X and Z values are 1, rest is 0. And Z. Z is in XYZ plane. So completely in 3 XYZ, 3 coordinates are 1. So Z equals to 1, 1, 1. And H. H is in Z and Y plane. Z, Y plane. So Z and Y values are 1, X value is 0. For H, X value is 0, Z and Y values are 1. So we write all the data points in the mention in the question. A is class 0 and D is class 0 and H is class 0. E also class 0. Rest are class 1. Rest all are class 1. There are two conditions, greater than theta and less than or equal to theta. So we find from these data points. So for example, we consider the data point A equals to all x, y, z values are 0. So that is x equals to 0. That is 0. Y hat output is 0. So the sum is 0. X less than or equal to theta. This is one condition we find. This is one condition. 0 less than or equal to theta. And the another condition, find when x value is 1. That is x greater than theta. And they mention in the question yz are always 0. In this question, in this data point B, z equal to 0 and y equals to 0. That is x equal to 1. So B equals to 1, 0, 0. So that is x, y and z. Always x, y, z are 0, x equal to 1. They mention in the question y, z are always 0. So this value, that is sum, x equals to 1 for x greater than theta. Greater than theta. So this is the another condition we find from this data points. So there in the mention in the question, the data points are linearly separable. That is, when the data points are linearly separable, only we can find the threshold value theta. That is, the data is linearly separable. LS means linearly separable. So from these two conditions, we find the threshold value. So from this, 0 less than theta means theta is greater than or equal to 0. 1 less than theta means theta is less than 1. Theta is less than 1. So this is 0, this is 1. So theta is greater than or equal to 0. This value, theta is 0, we include 0 also. Theta equals to 0 and greater than 0. These values. And the another condition is theta less than 1. Theta less than 1 in this region. Theta less than 1 in this region. So the threshold value is in between, that is theta belongs to in between 0, 1. So not include 1. So we include 0 also. Why they given in the question 0.1 to 0.9. Theta value between these values 0 to 1.9, then not include 1, only include 0. In this range, any value the threshold will satisfy. This is the answer.